on the history of electrical engineering, where electrical engineering as a profession has begun and where we are now. So we are saying now that electricity has been a subject of scientific interest since the early 17th century. So I know you know the 17th century simply means anything 1600s to 1700. That is the one that is referred to as the 17th century. So that is how old our profession is. What I would also like to tell you is that this is one of the oldest careers or professions. And the others, as we have seen, the likes of computer engineering, mechatronics engineering, computer science, and IT, all of them have their mother in electrical engineering. Because before we had electricity, we never had computers, and therefore those ones were non-existent. But when we got to an advent of electrical engineering, at least we were able to develop so much that we also got other sister fields or sons and daughters of electrical engineering. Electrical engineering is actually a mother to most of these other fields. This gentleman called Gilbert was one of the early prominent electrical scientists, and he was the one who drew the difference between magnetism and static electricity. And you can always study the difference, those ones that I think we have also seen them before. But anyway, as in your profession of electrical engineering, you'll also learn these differences. This man is credited with establishing the term electricity, and he also designed another device called Vasorium. You can always find out more, but in brief, it is a device that detects the presence of statically charged objects or bodies. Alessandro Volta is the one that developed the voltaic pile, the forerunner of electric battery, and it is after him that we have volt. Volt as the SI unit of voltage that was named after him. So it is in the 19th century, between 1800 to 1900, that is when now electrical engineering really developed, particularly with the discoveries that were made by Michael Faraday, who actually gave us the foundation of electric motor. That this man is the one who actually discovered the concept of a current carrying conductor. So if this is a battery, some cells or battery, he observed that if you place a compass in a current carrying conductor, that this is a conductor, this is a wire, a conductor that is carrying some current. So I want to be clear with that. So some current is flowing in this conductor. So that is why we call it current carrying conductor. So what he observed is that in a current carrying conductor, a compass is diffracted when brought near a current carrying conductor. And that diffraction is the one that is defined, it is caused by magnetic field, and that magnetic field is due to the current. So he actually observed some relationship between current causes magnetism and vice versa, that a moving magnet produces current. So that discovery was found out by this gentleman called Michael Faraday, and that was the very early stage of electrical engineering. So a lot has been said now regarding that. We are also saying that the research towards the growth of electrical engineering intensified around the 19th century, and notable developments in this century include that one by Christian Ørsted, who in 1820 discovered that current produces magnetic field, which diffracts a compass needle. And another man called William Sturgeon, who in 1825 invented electromagnet. I will be asking you about what some of these terms mean. So at this level, you should actually start getting to study on yourself and asking yourself, what is an electromagnet? What is an electrical relay? What is electric current? What is the potential difference? I will not now start defining each one of them for you, but at this stage, I will allow you now to start exploring the many concepts of electrical engineering, and some of these things I will test at some stage. So we are saying that it is around the 19th century that we have seen the development of electromagnet. Just to mention, electromagnet is if you take a small pipe, say about 1 inch, then you get a small wire, and then you turn it around, and then this electromagnet, you connect it to this side of the wire. You have now a wire that might be coming at this point. You connect it to an ammeter. Then now you get a magnet. One side is north, the other side is south. If you draw this magnet inside the pipe, this ammeter will show diffraction, that there is some current. This wire doesn't have any cell, but when you pull in or pull out this magnet, it will show some diffraction. So indicating there is some current that has flown inside that wire. That simply means that the motion or the movement of the magnet has caused some current to flow. So that is what is simply called electromagnet. It is a very useful tool because it is on this basis that we generate current, or we have generators and motors. They work on that principle of electromagnet. So this gentleman again, Henry, the units for magnetic field is measured in inductance. So the unit for inductance, which arises from magnetic field, is actually measured in Henrys, named after this man who came up with an electrical relay. And you also know that the unit for resistance is ohm, and therefore again it is named after the George Ohm, who in 1827 quantified the relationship between the electric current and the potential difference in a conductor. And I have also talked about the Michael Faraday, who came up with the concept of electromagnetic induction. James Clerk Maxwell came up with the concepts of electromagnetism. So these are just some fields that are very significant in regard to the development of electrical engineering. And they're important. So I just tell you about them so that you can know where we have come from as a profession. So there is plenty more that you can read for yourself. I will not really go through each one of them, but it is in your interest that you know where electrical engineering has grown from and where we are at this stage. So we can now briefly talk about the modern development, that during the development of a radio, many scientists and inventors contributed to the radio technology. And radio doesn't mean just the radio that you hear for when you want to hear some music. Radio actually means transmission of signals at radio frequencies. And there is a very clear category of frequencies. I don't know, I don't want to preempt the level of knowledge that you have, because I believe you should know by now what frequency means. That if you have a signal, you know, this is how most of the times we present a very basic signal that we might call, if this is my origin, this is the starting point. This is a signal that we basically refer to as sine wave. And this is one wavelength. We normally symbolize wavelength as that. F is the one that is used to symbolize the frequency. So we normally say that the speed of a wave, V, is given by lambda F, wavelength, or one cycle, from the point it is moving up to the point where it goes to the same point where it is moving up again. That is called one wavelength. So one wavelength, I mean, the number of cycles it makes. Frequency is the number of cycles it makes in 1 second. That gives you the speed. So what am I saying? That there is a very clear range of the radio frequencies that characterize the radio technology. And I don't want to give you figures now. We are going to be exposed to them. Just click this link and you'll get to know more about that. So we are saying that in the modern development of electrical engineering, that is where we have seen the growth of wireless transmission, electromagnetic radiation, like we have seen in hospitals, where we are able to use the likes of X-rays to get an image of probably a structure of the bones in a human body. The growth of radar and radar communication that is mostly used in the airline industry, among others. So what we are simply saying is that in the recent times, there has been a tremendous growth in the electrical engineering that you can, of course, attribute to what started in the earlier days of the 18th, 19th century. So what I would say is that we have had tremendous growth, and probably the last one that we have seen the major impact is that of the Apollo program. Without the electrical engineering being at the core of the growth. For if you don't know what is Apollo, you can always click this link. But it is the Apollo program that allowed scientists to go to the moon. The astronauts were able to use rockets and to go to the moon, and there is so much power that was involved, there is so much communication that was involved, and simply that modern growth of the communication industry or electrical engineering industry has allowed even the launching of the Apollo program to allow people or scientists to go to the moon. That is generally the growth of electrical engineering. So what I would say is that you can always read more for yourself and explore these ideas that I have allowed you to have put in blue. So you can always try to understand more for yourself, and you will be at a level where you are at a better position to know where the career of electrical engineering has come from and where it is today.